Hello and welcome to the review for Exam 1. I'm just going to jump straight in here. In Chapter 1, we start off with a introduction to chemistry. I'm not going to test you over the stuff here at the beginning of the chapter, where I'm just kind of introducing the topic, talking about chemistry in general and how we view chemistry. When we get to the scientific method, mainly what I'm looking for here is that you can identify the difference between a hypothesis, a theory, and a law. Those are the main three things that I want you to be able to tell the difference between. So understanding what a hypothesis is, how a hypothesis is different from a law, and how a law is different than a theory. Understanding those the differences between those things is what I'm mainly looking for when it comes to the scientific method. Now, when we get into some actual chemistry here, classifying matter, I do expect you to be able to classify matter based on all the stuff that we talked about through here. And there will be at least one question on the exam that covers things like this, where you need to classify either as a solid, liquid, or gas, or what is present, although probably not what the structure is. We didn't really get into that. It's more so going to be the phases, or even more so the composition, what's present. So the phases here, the differences between the phases is what I'm looking for mostly, that you can identify just in general. What makes a solid, what makes a liquid, and what makes a gas a gas. Plasmas, I'm not going to test you over those other than just to know that they are the most common form of matter in the universe because they're the sun, stars are made of plasma. That's really the only thing I expect you to know from that. So when we get into classifying things based on what is present in the material, I do expect you to be able to classify things as either an element, a compound, or whether it is a mixture that is heterogeneous or a mixture that is homogeneous. So you should be able to classify a sample based on all or into one of those four categories. And so we talked about that a bit here in the slides, which I won't go into again now, just for the sake of time, but if you need a refresher on this, just go back and watch those videos. Physical versus chemical properties, I also expect you to know how to identify these. So if I were to name one or two different things and have you classify them as either a physical property or a chemical property, you should be able to do that. And most likely that will be on the exam. That's a fairly easy, quick question that I consider to be essentially a freebie. Because there are very few things. Every once in a while there's one or two things where it can be kind of hard to tell whether it's a physical or chemical property, but for the most part, if you understand what a physical property is, something that is displayed without changing the composition, and that a chemical property is something that is displayed by changing the composition. If you understand those differences for almost everything, it's pretty easy to tell whether something is physical or chemical. Okay, so that's just more of the same stuff there. So when we get into the units here, there's a long discussion about units, where they come from, and how we use them. The main thrust of this section here is not where units come from. I'm not going to be testing you over, where does a kilogram come from? Where did a meter come from originally? Sorry about that. Had to go help my kid with something. So anyway, back with this here. I'm not expecting you to know where the units are coming from. The most important thing is how to use them, or more specifically, converting from one to another. I do just in the general sense expect you to know what the units are describing, of course. So I'm not going to explain what a meter is. It's a unit of length. That's something that you should know already. But other than that, that's really all I expect you to know from those. The most important thing is this, dimensional analysis. There will be a significant amount of dimensional analysis in the exam. I forget exactly how many points worth of questions there are, but I want to say it's something like 15 to 20 points worth of dimensional analysis in the exam. So possibly a fifth of the exam in terms of the number of points will be dimensional analysis. And that's because it's very important for you to be comfortable and to be proficient at doing dimensional analysis. So be sure you know how to convert from one unit to another. And so that's what this whole section through here is, including this stuff here with temperature, which I do expect you to be able to do as well. So scientific notation, I do expect you to be able to read numbers in scientific notation. There aren't any questions where I have you just write out a number in scientific notation, just because that wouldn't really work in Blackboard. But you should be able to read scientific notation and understand scientific notation, because I will put numbers into questions in scientific notation. Unit prefixes, kind of the same thing earlier as units, just units in general. You should be able to convert from one unit to another inside of these unit prefixes. I do expect you to be able to do that. And sig figs as well. I do expect you to be able to answer a question with correct sig figs. And there will be at least one question on the exam where I will have specifically stated in the question, give your answer with correct sig figs for full credit. Now I might also put in a question where the entire point of the question is just sig figs. So it's just kind of a random calculation, and then your job is to provide the answer with correct sig figs. But more likely I will give you a question where at the end of the question it just states that if you want full credit, you should do exactly correct sig figs. But that will be in at least one question on the exam. Okay, so there's just more stuff about sig figs. Density, you should know how to handle density in either to find the density or use the density to find either the mass or the volume, if given one or the other. And that will be on the exam as well. I believe there's just one question about density, I think. But don't hold me to that, but I know there is at least one question on the exam over density. I believe, then the accuracy and precision. As far as accuracy and precision, what's written there is really just what I expect you to know. Accuracy is how close measurements are to a correct value. Precision is how close they are to each other. That's really all I expect you to know. So that is Chapter 1. Chapter 2, getting into more chemistry here, talking about the history of chemistry specifically. Let's see, so this history stuff here at the beginning, there's not a whole lot of this that I expect you to know. The main thing I want you to know from this is that Dalton was the scientist that proposed the atomic theory. You do not have to have the different sections of it memorized here. I expect you to know that Thomson discovered the X-ray, or sorry, not the X-ray, the electron. So here you have Thomson discovering what he called at the time cathode rays, but we now know them as electrons. And I expect you to know that Rutherford developed what we call now the nuclear theory. So that is the theory that you have the nucleus in the center with almost all of the mass, and then the electrons around it. So those are as far as the history stuff there, that's all I expect you to know. So again, just to reiterate, Dalton had the atomic theory, Thomson discovered the electron, Rutherford developed the nuclear theory. Okay, so now we're getting into talking about all the different parts of the atom here. I do expect you to know just generally the information that's shown here about protons, neutrons, and electrons. You should know that protons are positively charged, electrons are negatively charged, neutrons have no charge, and that electrons are much, much smaller than protons or neutrons. So here we're just talking about and when we change these things, what happens. I do expect you to know what's described on this slide as well. So changing the number of electrons gives you an ion. You should be able to tell the difference between an anion and a cation. Changing the number of neutrons in an atom gives you a different isotope. And then changing the number of protons gives you a whole different element. I expect you to know all of those things. Any of those would make a nice, easy, true, false, or multiple choice question. Writing or reading elemental symbols is another thing that you should be able to do because it will be on the exam, I guarantee it. So on the exam at some point, I will give you something like one of these, and then you will have to fill in the number of protons, neutrons, and electrons for that element. So, for example, here on this chlorine, if you remember in the slides, we worked out how many protons, neutrons, and electrons there were for this particular chlorine isotope. You would be doing the same thing on the exam. Now, some of these, if you remember, we said, well, we're just going to assume, because there's no mass number given, that has the same mass number or it's closest to the mass number on the periodic table. I will go ahead and give you the mass number on all of those. It won't be a question. They won't be wondering, do I round up, do I round down? There'll be no rounding. I will give you the mass number. But there will be questions on the exam where I give you a elemental symbol, like this one, and you tell me the protons, neutrons, and electrons. I considered trying to put something in where you would actually write the symbol yourself, and the formula writing methods for in Blackboard are just not terribly great, and so I just couldn't come up with a good way of doing that, unfortunately. So here we're talking about the periodic law. I do expect you to know just generally the periodic law, how there are properties that reoccur periodically as you go down a list of the elements. I expect you to know the different regions of the periodic table in terms of metals, nonmetals, and metalloids in the middle there. As far as the just general properties of metals versus nonmetals versus metalloids, I'm not going to test you over those. I do expect you to know the group names, or at least some of these group names. I believe I mentioned these in the video as well, but just to reiterate, you should know the halogens, the noble gases, the transition metals, the alkali metals, and the alkaline earth metals. You should be able to identify the names of the columns there, those groups. You should also be able to predict the charge of ions based on where the element comes from on the table. So if you remember, that was +1, +2, +3, -3, -2, -1, and then these don't form ions at all. So you should be able to work out the charge on ions from those, just from where it is on the periodic table. And I also expect you to know the 7 diatomic elements. You should have those memorized. And if you remember, it's fairly easy to remember where those are if you have a periodic table, because they make a nice little 7 right here, and then you have hydrogen up there. Okay, as far as atomic masses and finding atomic masses using the different isotopes, that is something that you should know how to do. I don't remember off the top of my head if I put one of those in the exam or not, but you should know how to do that. It's not one of the more important topics of the exam, but it is something you should know how to do. Okay, when we're looking at elements versus compounds here, we're starting to get into how elements combine together. I do expect you to know the difference between ionic bonds and covalent bonds. So covalent bonds are where atoms share electrons between each other, and ionic bonds are where one atom steals the electrons. You should be able to tell the difference between those two. Remember that covalent bonds are always between two nonmetals. Ionic bonds are between a metal and a nonmetal. And when we represent these things, we have a few different ways of doing that. I'm not going to test you over these here. I'm not going to give you a structure and be like, what's the name of this type of formula? This is just kind of to introduce you to how we represent them. But you should still be able to read them, obviously. So if I give you this, you should be able to tell me, well, there's 1 magnesium, 2 nitrogens, and 6 oxygens. Okay. So now we're getting into forming molecules and naming them. So this is another topic here that is guaranteed to be on the exam, both in terms of, if you have a metal and a nonmetal, what molecule would it make? Making sure the charges match up there. That is something that will be on there, and it will probably be linked into naming as well, because those are very, very closely related for some of these things. So there will be nomenclature on the exam, a decent bit of it. So make sure that you know how to name all of the different groups, if you will, or different kinds of molecules that we talked about here, that being ionic molecules or compounds in any of their forms, as well as not hydrated, by the way. Hydrated compounds are not going to be on the exam. But all the other ionic compounds, as well as molecular compounds, so these are 2 nonmetals bonded together, as well as acids and bases. So know how to name all of those different kinds of molecules. Alright, moving on to our last chapter here. This is over mostly moles and molarity here, but we started off the discussion talking about donuts, comparing the idea of a dozen to the idea of a mole. So I do expect you to be able to use Avogadro's number to convert between a number of moles and a number of things. That is something that will be on the exam. I also expect you to be able to convert from a number of grams to a number of moles using the molar mass from the periodic table. That will also be on the exam. So there'll be a good number of questions converting from grams to moles using this kind of a process here, going from here to here. And there will also be questions where you will go through this whole conversion process, going from either mass all the way to number of atoms or molecules, or vice versa, going back from molecules to mass. And so make sure you know how to do that, because like I said, those are guaranteed to be on the exam. Percent composition. I don't remember if I put that on there or not. Hold on, let me go check. I'm going to pause the recording again and go see if I put that on there. Okay, so from a quick look at the exam, I did not put any percent composition questions on there, so you don't have to worry about this one for the exam. And also, by the way, I did not put any questions on there where you would have to find the molar mass using different isotopes and their abundances and stuff like that. I went ahead and checked on that as well. As far as solutions, which is the last topic of the chapter here, I do expect you to know the difference between a solute and a solvent. And I expect you to be able to find the molarity of a solution if I give you the data to find it. So if I give you the mass of a solute and information about the solvent, you should be able to find the molarity, the moles per liter. In addition, you should be able to use the dilution equation to work out what the concentration of a solution would be after it is diluted, or the original concentration of a solution before it was diluted, whatever. You should be able to solve for any part of this equation here. Just so you are aware, there will be questions about dilution on the exam, and there's questions about molarity on the exam. So make sure you know how to find the molarity and use it, and how to use the dilution equation for the exam, because you will be asked questions about those two topics. Alright, so the last bit here with the mass percentage, parts per million, parts per billion, and then the volume percentage, mass volume percentage, those are not on the exam. If you come back for General Chemistry 2, we will talk more about these different kinds of concentration units. We'll have a whole chapter, actually, over solutions, not just this one little section of a chapter that we have here. So we'll talk more about those in the other class. But for now, I will not test you over those. The only unit of concentration that I will test you over is molarity, as it is by far the most common one. So that's it. If you have any questions about the exam, feel free to email me. I apologize for the interruptions in the middle of the video here. This is what happens when it's freezing and snowing, and you're here at home with your kids by yourself trying to get work done. Stuff like this happens, I'm sure most of you know. So I apologize for that, but hopefully you'll be lenient with me on there. So just let me know if you have any questions, and good luck on the exam.